Hello, everyone. Thank you for joining us. This is the monthly update from the EVerest team, the Technical Steering Committee. As always, we have to quickly show this antitrust policy, so please be aware there might be competitors on this call, so if you ask a question afterwards, only share what you want to share. Okay, so let's go. We have quite some interesting updates, but before we go into that, let's quickly recap what we're doing, why we're doing it, and where we stand. So this is a big ecosystem from the NF Energy, where there are a lot of open source projects regarding renewable energy transition. And EVerest looks small, but it's basically the interface from the electric grid of the future to the cars of the future. And by that, it has the potential to control up to a third of the future electricity. Next, so why are we doing that? So there's a big ecosystem of multiple players trying to create chargers of the future. Everyone is basically replicating all the standards necessary for charging a car, and that's actually a lot of waste of time, and you also end up with inconsistent technologies. Things don't work with each other. So we think it's better to do that together, and we will save everyone a lot of cost. We will save the customer a lot of pains if things just work. And what we're aiming for is the firmware within the charger, which connects local solar, grid, cars, humans, and the cloud, and all the embedded electronics, and that in a really customizable way. And if we look one level deeper, we have a lot of interfaces and protocols to certain things like grid, batteries, other consumption, other chargers next to you, the cars, the payment clouds, the humans, and some forecasting APIs in the web. So this is kind of the picture where you want to go. Not everything is done yet, but we're heavily working on that. And why we're not doing it with just a better standard, and instead of implementing all those old standards, if we would just create a new standard, we would have just more standards, but not solve the actual problem. So what we're aiming for is getting reference implementations for all of that combined together to have a nicely working system. So everyone, for example, you could build products on top of that, amazing ones. And if you want to help with that, PIONIX is there for you. So, for example, we have a development kit. We're starting to ship in bigger quantities this summer, and small engineering samples you can get already now. And basically, it's a Raspberry Pi with charging on top of that, so you can have fun and really, really quickly go into productive mode with your software before even your actual hardware is ready. So if you have interest in that, please contact PIONIX. So, and now I will hand over to Cornelius. What's new?
Yeah. So what has happened since the last 4 weeks update in the last TSC? Marco, you think you can just start the video? It's long anyway. So we did a lot of work on the admin panel, which is basically web interface to configure EVerest. So you can see you can already open up like the real configurations. You can see all the modules arranged in the right part. You can zoom in, drag it. It's a little bit similar to Node-RED, and you can basically load all modules. So you can see here in the example that we're loading an OCPP module that we can drag to the place. We can configure the module, for example, rename it or change some of the other module configurations. Below there's like info buttons that show you what it means. And finally, if you arranged everything, you can basically draw the connection to attach it, in this case, to an EVSE manager, which is the actual charging module that charges the car. And basically that's it. So what you just saw is you configured a charging station to use an OCPP client to talk to some backend. And since it's like a nice graphical tool, you can basically arrange it in any way. You could, for example, also load a second EVSE manager if you have 2 charging ports, and you can attach both of them to the same OCPP client or to 2 different ones. So you can also load modules twice. So it's super flexible. And once this is basically finished, you don't have to deal with like all the text configuration files anymore to do this. You can just edit everything in a nice graphical fashion. And once this tool is more complete, it will also serve as a setup tool for the technician who's installing the charger to configure some things while installing, to set things up, for example, set fuse limits, like in this example. Yeah, so this is Like the very first basic version is about to be finished soon, and then it will also be open source. Right now it's still hidden, but once it has the basic functionality actually working with the real EVerest stack, we'll publish it, and this will probably happen within, let's say, days, maximum weeks. No. So yeah, this is one of the really cool features coming up pretty soon now. Yeah, next slide.
Yeah, 1 second.
Yeah, about the OCPP, in the last update, we already showed that we're more or less complete with only a few things missing. So now basically OCPP 1.6 JSON is complete with all the profiles. So we include, of course, the core profile as everyone, but it also includes like all the additional ones such as firmware management, local authorization lists, reservations, smart charging, and remote trigger. And we also improved security quite a bit. So the security profiles 1, 2, and 3 are more or less done and in testing now. And we're still testing everything in all cases against the OCA compliance test tool to make sure it's compliant to the OCA standard. And if you want to work with us, actually, it's a really nice chance to meet us live next week in Arnhem, the Netherlands, where we'll be on the OCPP Plugfest. So you can also meet us, have fun with us, and actually play with the implementation. Yeah, and what's next on OCPP is that we support the 15.11.8 plug and charge extensions that have been backported from OCPP 2.01, and we'll also support the non-standard but now frequently used auto charge option.
It's one of those many white papers which extending OCPP in all kind of directions.
Yeah. Okay, let's just see, Marco, the image ended up on the wrong slide. But anyway, the image was probably meant for the next slide. So changes for the framework. There was a lot of background work going on, especially around handling of timestamps. So it should now be in a very consistent state of using UTC timestamps everywhere. We had some issues before where when the system clock is running on local time, sometimes you get differences between the modules and how they handle time. This should be fixed now. And we have some preliminary support for modules in Python 3. So up to now, we basically support C++ and JavaScript, but we'll be working on getting Python module options on board as well. So again, our strategy here is that all the core modules will be C++ simply for efficiency and to make sure that all the core functionality is available also on really small CPUs and stuff. But for like quick extensions, JavaScript is a nice option in Python definitely as well. So next slide.
The display?
Yeah, the display, that should have gone on the display slide. I just copy and paste it to the wrong one. Okay, but yeah, go on to the ISO.
Oh, yeah, okay.
Yeah, on the ISO 15.11.8 stack, so we basically stabilized the interfaces now. We have a more or less working implementation based on the RISE V2G, but we'll replace that in the future with probably 2 different stacks that come with the same interface. So in the end, you will be able to basically drag and drop, exchange them in the graphical tool that I showed earlier, and just drop in another ISO implementation and you're good to go. So in the end, you will basically have a choice between multiple different ISO implementations. Yeah, we're currently working on getting full support of ISO 15.11.8 in the car simulator of the software in the loop simulation module. This will probably be finished next week. It's almost done, which means we can basically do full ISO sessions and all tests all on your laptop without any external hardware, where the software and the loop modules really communicate via ISO stack with the simulated charger. Yeah, and concerning ISO, if you want to meet us and want to play with us and have fun, we'll be on the Charian Festival in Zielona Góra in Poland at the end of the month. So hope to see some of you there. About the display app, this was basically the image that we had earlier. We have like the minimal viable product ready now, and it's going to be open source within the next couple of days. It's an implementation in Flutter. So it kind of serves as a starting point, and you can easily make your own display content with that, because Flutter is really nice in making beautiful apps for a display. It also comes with an API and a setup module in the EVerest core. The API basically gives easy access to status information and simple control commands that the Flutter app uses, for example, to pause the charging or to show how many kilowatt hours have been charged. And the setup module is focused more towards chargers that run in a home environment, and it can basically set up things like Wi-Fi, time zone, update mechanisms and stuff like that. So it's essentially the backend for the configuration for the home user, not for the public one. All right, next slide, please. Yeah, we also updated our roadmap a bit. Just a word of warning, the prioritization here changes quite often. It always depends on what the community actually wants and needs and likes to contribute. But our basic idea here is that like this summer we'll have kind of our first stable release with like everything working that we want to support up to now. That basically means AC charging both in IEC and in 15.11.8-2. Fully tested and working. We have OCPP 1.6, which is basically already now working with all the extensions. The display app will support all features that the stack has. Right now it's a bit minimal. And the energy management will support at least price-driven charging and solar optimized charging with local communication to the solar inverters. Towards the end of the year, we have some plans to support a lot of stuff for German Eichrecht, basically drivers for power meters that do signed metering and all that stuff, all the way up to the cloud. And also to support like local credit card payments. This is one of the requirements in Germany now, to get a local payment option on all chargers, and we'll have that as well, of course. The newer ISO stuff, the -20, we currently at least shifted a bit out to next year because there are currently no cars we can test this with. But it will definitely come to support bidirectional, and we're already supporting bidirectional energy flows in the energy manager in the background. So it's like all prepared and to integrate this. Yeah, and support for OCPP 2.01, EEBAS, USEF, ADR. These are protocols we'll support as well, but do not have the highest priority at the moment. But as I said earlier, the priorities may change. So if there's somebody really needing this right now, we may, of course, shift this.
Especially OCPP 2.0. So what we saw in the market is that not so many people are really using it. So we think other things have a more higher priority for now, but let's see. Okay, next.
Yeah, maybe one more announcement. Yeah, let's go camping with us. We'll be on the MCH 2022. It's a hacker camp in the Netherlands towards the end of July. And we have our own camp there. So there's an EVerest base camp where we will have a couple of cars. We'll have chargers there. We'll have our tents there. We'll be hacking cars for a couple of days. So feel free to drop by when you're at the event. Have fun with us. Yeah, and hack some cars.
Then thanks for your attention. I will now stop recording, and then everyone is free to speak up.